Hi, welcome to the Calculus 1 lecture series. And this is the unit number 3, application of differentiations. This is our lecture number 23. This is the second video of our lecture number 23. And at the end of our first video, there's the internet issue. So it's kind of like get cut out right when we finish the problem number 1. So now let's go ahead and start the problem number 2 here. How we do the optimization problem? Okay, so let's go ahead, go back to our lecture notes here. Okay, so we finished problem number 1 from the video number 1. We also list 6 steps and how to do is kind of like a guidelines, how to do the optimization problems here. Okay, so now let's go ahead and start. And number 2 here is tell you a cylindrical cup is to have a surface area of the 12 square inches of aluminum. What is the largest possible volume of such a cup here? Okay, so remember, let's do the step by step. So remember the step number 1 here. That means define the known and the unknowns, right? So let's see, what is the known here? Not much. So we know the surface area. So the surface area is 12 square inch. So what is the unknown? Several things is unknowns here. So we don't know the volume of this cylindrical cup. We don't know the radius of this cylindrical cup, and we don't know the height of this cylindrical cup here, right? So those are the 3 things we don't know. Okay, now the second step, like we defined in the step to optimize the, do the optimization problem is to draw a picture. So we say picture in the say about 1,000 words, right? So it's better than 1,000 words. So let's draw a picture. So this is our cylindrical cup here. All right. So now we'll say in here, this is my radius R, and this is my height. I label it, right? So I labeled it, and so it's the radius and the height, and I want to find the, the volumes, right? So number 3 is here. We try to label that. So the V is the volume of the cup. So we know for the cylindrical, so this is the one we want to maximize this, right? Then we know the H is the height, and R is the radius, like we show in the graphs here. Then the step number 4 is to try to find the relation between among all these variables here. So we know the V is pi R square times H, right? So it's pi R square times H here. And now, okay, so I want to find the relations here between the height and the radius. Okay, so this is what we want to maximize here. Now let's take a look at how do I convert one variable to another. Okay, so we know the total surface area is 12. So remember, right? So for the cylindrical, the surface area, that means you including what? You including the bottom and the top. Also, you have what? Also, you have like this kind of surface areas, right? So you also have this surface areas around. So I know when, when we were in the geometry class, so we know the total surface area. So when you open this up, this will be a rectangle, correct? So will be the height times the circumferences. So this height is h times the circumference is 2 pi r. So let me highlight here. So 2 pi r h. So this is the blue area, and the plus I have a top and the bottom lids. So it's a 2 times pi r squared here, right? So there is a 2 times the pi r squared. Oh, so this is an open cup. I'm sorry, see here. So in here, I guess we did not assume the top here. So that means I only have one button, so in order to hold that, you need to have the button. So in here, they did not spell clearly. They did not say we have a top lid. They just say it's a cup, right? So it's a cup, it doesn't have a lid there. Okay, so this is our relations here. Now I want to, so this is a pi r squared here. So when you add these two is equal to what? Is equal to 12. So I want to solve one variable to become a function of the other variable. So for this ones here, obviously I want to solve the h, because h is easier to be a function of the r. If you try to solve r to be a function of the h, because you have square, so you might need to take the square roots. So I will say, okay, so h is easier. So h is 2 pi r here. So this is 12 minus pi r squared, right? Okay, now I can substitute. So now here, number 5 is here. Step number 5. So volume is the pi r squared times h. So this will be the pi r squared. H is what? Is 2 pi r. 12 minus pi r what? 12 minus pi r squared here. Okay, and now in here we can simplify a little bit. So in here we can say the pi and the pi here is cancel, and so the r, I can cancel r, and now the 2 you divide by there, so this is r, then this is 6 minus 2 pi r squares, right? So now so now we need to find the domains here, because this is the r, and the r, so the domains here is the value of the r's, right? So r can be 0, and also the r cannot, so here that means this one is here, the 6 minus pi over 2 to the r square equal to what? Is equal to 0, right? So the r square, okay, is going to be equal to the pi over 12. So r, the largest value of r will be the square roots of the 12 over pi. So the domains here, I know this is 12 over pi square roots here. Okay, so after that, then the step number 6, it become easier. We just use, so if you want to simplify this a little bit, you will say this is a 6r minus pi over 2 r the cube here. Okay, now the step number 6 here, you will find the derivative, right? So we use the VR, I should say VRs here, because this is the R is the radius here. So it's a VR. Okay, so the derivative of the VR, so this is a 6 minus pi 2 and 3 times R squared. Correct? Okay, so now I will set this equal to 0 to find the critical points. So then in here, the 6 is equal to the pi over 2 times 3, the r squared. And then I can simplify that. I will say the r squared. So you divide it by pi and times 2. And so you will simplify, do your little algebra. So r squared is equal to the 4 over pi. So what is the r here? R is the 2 square roots of the pi. You cannot have negatives, right? And now let's see here. So now let's see, now if you take a look at the second derivative, the second derivative, you will have a negative 3 pi r. This is less than 0 by the second derivative test. So when the less than 0, then you say the maxima exist at r is equal to 2 over square root of the pi here. Okay, so I know the maxima volumes, right? So at r is equal to 2 over square root of the pi. So now my volumes here, pi r square. Okay, so the volume will be the, here we just did, so this is 6 times r, so it's 2 square roots of the pi minus pi over 2, the r square is 2 the square roots of the pi to the cube here. And then this will give you a over square roots of the pi inch cube. So I know this is my max volume. Of course, at the boundary, if you put a 0 there, it will be what? It will be 0. And if you put the largest r, then it means the height will be equal to 0. So it will be 0. So this will be my maximum volumes here. All right. Okay. Now let's go to the next ones here. So the next ones here is we talk about find the dimension of the largest rectangular pack that can put into a round holes with a diameter of 10 centimeters here. Okay, so now let's just like put our step number 1. All right, so step number 1 is here, known and unknown. Okay, so let's take a look at the known. Okay, so the known things is, oh, we know the diameter, right? So the diameter of the hole is 10 centimeter. We know that. And so what is the unknown? So that we want to find the rectangulars, right? So we know the dimension of the rectangular is unknown. All right, and the area is unknown, right? And the unknowns here. So both we have all this is unknown. Okay, so now number 2 is here. Okay, so let's draw a picture. Okay, so in here, let's see here. So I have a hole or a peg. Okay, so here, so this is my circles, right? I hope I can do a good circle. It's very difficult to draw a circle freehands, all right? Okay, so this is my circles here. I want to put a rectangular pack into there, right? So here, this is my rectangular pack into here, okay? And then I know the diameter. Diameter is what? Is 10. That means from here to here, this is 10 centimeter. Okay, now I want to find what here, find the diameter of this rectangular pack and put around the hole. Okay, so the largest, right? So that means that the area is here. Okay, so now let's try to write down the label. Okay, number 3. We want to find the largest pack. Largest pack. That means the largest area. Okay, so let's say the area is 8 here. And then we need to know the dimensions. Okay, so let's try to label the dimension. So this rectangular. Okay, so now in here, if this is the coordinates x, y, that means this is x, right? So I know this is x, This is x, the length is here. And then this is y, and this is y here, right? So the equal length is here. So that's why I know the, okay, so that's the y is the, so this is the x. Let me highlight that, maybe it's easier to see. So this is x, this is another length of the x, and also the same way for the y. So this is the y here, right? So the one segment is y, so the whole blue segment is 2 y's here. Okay, so now the problem getting easier. So now I want to find the areas, right? So the area, we are talking about the whole this areas, right? So we are talking about the areas, all these light pink areas here. So it's the length times width. So this will be the 2x times what? 2x times 2y's here. All right. So the 2x times 2y. So this is 4xy. Okay. So now I need to the step number 5 here. I need to change all to the one variables here. So this is the coordinates, right? X, Y. So XY is on the circumference of this circle, and the diameter is 10. So I know by using the circle formula, I know because any points on the circles, right? So I know that x squared, x minus origin, in here we put the origin as 0, right? So we know the x squared plus y squared equal to the r squared, right? So that's what is the formula for the circle, is x minus h squared plus y minus k squared equal to the r squared. H and k are the centers, right? So right now the center is at 0. So the diameter is 10. So what is the radius? Is 5, right? So it's 5 squared is 25 here. Now we say, oh, okay, now in here, I can change the y is equal to the square roots of the 25 minus x squared. Okay, so it's not too bad. So now my areas here is 4xy. So I can replace all this will be 4x and the times this is 25 minus x squared. Okay, and then let's take a look at what is the domain for x. So the domains here, the x, the smallest one can be what? Can be 0. And what is the largest one? If it's the whole here, so it's 5. Right? Okay, so the diameters here, right? So the diameters, the largest one, it can be 5. That means y going to be 0s, right? Okay, so now the step number 6 here. All right, I can take the derivative. So a prime x here. Now this is all back to the calculus. So I need to do this. What rules we are doing? Product rules, right? So I take the derivative of the first one. So it's 4x is the derivative just by itself is 25 minus x squared. Then plus 4x. Take the derivative of the second term. So this is 1/2. So this is 25 minus x squared. So 1/2 minus 1 is negative 1/2. And don't forget the chain rules, right? So it's negative 2x here. Okay, so now let's simplify a little bit. Okay, so 4 and 4, I can take it out. So this is 25 minus x squared. And this 2 and 2, I can cancel that out. And so this is minus, then the x times x is x squared. Then I have a 25 minus x squared. Okay, now use your algebra to do the common denominator. So the common denominator is 25 minus x squared. Okay, so because this 25 minus x squared, so what happened to here? This will be what is 25 minus x squared, correct? Okay, then you minus the x squared here. Okay, so now I will set the first derivative equal to 0. So we know in order to for the fraction equal to 0, that means the numerator will be equal to 0, right? So I know the 25 minus 2x squared equal to 0. So the x squared is equal to the 25 over 2. So correct. So now we can have the x is equal to the square roots of that. So it's 5 over the square roots of 2, or you rationalize it, it's 5 square roots of 2 over 2 here. So this will be, okay, so I know this will be the largest, the largest values here. So if you like, you can continue to take the second derivative. You find that a double prime x is negative. And if it's negative, then you know this is what? So this is the maximum point. Or you can just use like the like the check for the first derivative test. This is 5 square roots of the 2 over 2. I know this one, the second derivative, the second derivative is not easy. So you said if it's less than here, if x is less than 5 over square roots of the 2, if it's less than, what happens here? Your first derivative is going to be what values here? If it's less than, would be positive, right? Positive. And it's greater than, your first derivative will be negative. And then I know for the positive, if it's positive, your function is increasing. It's negative, your function is decreasing. That's why these ones here, you're going to have a max here. Okay, so let's just try to double check here. So now I can find that the y is equal to, because we defined y is equal to 25 minus x squared. So I can find that the y is equal to the 5 of the square root of the 2 over 2. So I know that the largest cross-section area will be what? Will be a square here. All right, so then that's why I said a square pack, right, will get, will fits in a round hole. That will give you the largest pack here, right? So that's why a square, that's the dimensions here, the x and the y, they will be the same length here. Okay, all right, so now let's take a break here, and we'll come back to finish our the remaining other two problems here. Okay, I don't want each video last too long here. Okay, so talk to you in our next videos here. All right, bye.